Have you ever gazed up at the night sky and wondered what bizarre otherworldly places might be out there? The universe is filled with exoplanets so strange and extreme that they defy imagination. From planets hotter than stars to worlds made entirely of ice, these discoveries redefine what we thought was possible. Join us as we take a journey to explore the 10 strangest exoplanets discovered so far. Each one will blow your mind, so stick around and let's dive into the cosmos together. Kelt 9b, a scorching inferno. Meet Kelt 9b, a planet so blisteringly hot it challenges the boundaries of planetary science. Orbiting a star twice as hot as our Sun, this gas giant experiences daytime temperatures exceeding 7,800 degrees Fahrenheit. That's hotter than some stars. The extreme heat has stripped the planet of its atmosphere's molecules, breaking them down into their basic atomic components. This planet orbits so close to its host star that a year lasts only about 1.5 days. Its proximity causes it to be tidally locked, meaning one side is perpetually facing the scorching star while the other remains in darkness. Scientists speculate that the night side might be slightly cooler, but cooler is relative when the entire planet is engulfed in unrelenting heat. What makes Kelt 9b even more extraordinary is that it's gradually evaporating. The intense radiation from its star is blowing its atmosphere away into space, creating a glowing tail, much like a comet. This phenomenon provides astronomers a rare glimpse into atmospheric escape, a process that's reshaping our understanding of planetary evolution. Traveling to Kelt 9b isn't an option, it's inhospitable beyond imagination, but studying it reveals how diverse and extreme planets in our universe can be. It's a fiery example of how exoplanets push the limits of what we consider possible in the cosmos. Gliese 436b, the ice on fire world. Gliese 436b seems like a contradiction of nature. Imagine a planet covered in burning ice. Located about 30 light-years away, this Neptune-sized world defies expectations with its bizarre mix of heat and ice. Its surface temperature is a scorching 800 degrees Fahrenheit. Yet water exists as a solid ice mantle, compressed by the planet's immense gravity. This scorching world has a thin atmosphere, primarily composed of hydrogen, helium, and methane, which traps heat. Despite the intense temperatures, the high pressure on the planet keeps water locked in a strange, solid state called hot ice. This exotic form of water remains stable even under extreme heat, an incredible reminder of how physics behaves differently in alien worlds. Adding to the intrigue, Gliese 436b completes an orbit around its host star in just 2.6 Earth days. This tight orbit means the planet is exposed to constant stellar radiation, which further accentuates the paradox of its fiery, ice-covered surface. This otherworldly discovery shows how diverse exoplanets can be, challenging our understanding of what's scientifically possible. Gliese 436b is a testament to the universe's endless creativity, blending fire and ice in a way that can only exist far beyond our solar system. HD 189733b, the glass rain planet. Known as Osiris, HD 209458b is a gas giant slowly being ripped apart by its parent star. Located 150 light-years away, this exoplanet is losing its atmosphere to space at an astonishing rate due to its proximity to its host star. It's a perfect example of a hot Jupiter, a gas giant orbiting extremely close to its star. Osiris experiences extreme ultraviolet radiation that heats its atmosphere, causing hydrogen and helium to escape into space. This process forms a massive tail of gas trailing behind the planet, making it resemble a comet more than a traditional planet. This tail stretches thousands of miles and offers a fascinating glimpse into planetary disintegration. Astronomers have even detected heavier elements like oxygen and carbon in the escaping atmosphere. This discovery is groundbreaking, as it allows scientists to analyze the chemical composition of an exoplanet's atmosphere in detail. The fate of Osiris provides an eerie glimpse into the potential endgame for other exoplanets orbiting too close to their stars. It's a powerful reminder of the delicate balance planets must maintain to survive the harsh realities of space. Kepler 16b, the Tatooine planet. Kepler 16b is a real-life version of Tatooine from Star Wars, a planet that orbits not one but two stars. This celestial oddity is located about 200 light-years away and is a gas giant roughly the size of Saturn. its dual suns create a surreal, ever-changing skyline that alternates between single and double sunsets. The planet lies in a circumbinary orbit, meaning it revolves around both stars as they dance together in a cosmic waltz. Despite its dramatic skies, Kepler-16b is surprisingly cold, with temperatures averaging around -100 degrees Fahrenheit. This chill is due to the distance from its host stars, which provide just enough light to illuminate its surface without warming it significantly. Kepler-16b's discovery confirmed that planets can form and survive in binary star systems, a finding that expands the possibilities for where planets might exist in the universe. This revelation has inspired scientists to explore the dynamics of binary systems further, opening the door to more discoveries in the future. Though uninhabitable, Kepler-16b sparks the imagination with its resemblance to science fiction worlds. Its existence proves that the universe holds surprises beyond anything we could dream up in fiction. 55 Cancri E, the lava world. 55 Cancri E is a planet of extremes. Found 41 light-years away in the Cancer constellation, this rocky super-Earth is locked in a perpetual furnace. With one side permanently facing its star, the planet experiences temperatures soaring over 4,400 degrees Fahrenheit. On the other side, where starlight never reaches, temperatures plummet drastically, creating a world of stark contrasts. This hellish planet is theorized to have rivers of lava flowing on its day side. Its surface glows with molten rock, illuminated by its blistering star. Scientists also suspect that the planet's atmosphere is dense with vaporized minerals, adding to its fiery ambience. The interaction between the extreme heat and the planet's unique geology creates an environment where lava oceans could exist, constantly churning and reshaping the surface. What makes 55 Cancri E even more captivating is its unusual orbit. A year on this planet lasts only 18 Earth hours, meaning it hurtles around its star at breakneck speeds. The extreme proximity to its host star also causes significant tidal heating, contributing to its molten state and making it an active and volatile world. As bizarre as 55 Cancri E sounds, its study offers scientists valuable insights into planetary formation under extreme conditions. This lava world is a testament to how planets can evolve into scorching wastelands that challenge our perceptions of habitability. WASP 12b, the planet being consumed. WASP 12b is a doomed world, slowly being devoured by its host star. Located about 1,400 light-years away, this gas giant orbits perilously close to its star, completing an orbit in just over one Earth day. Its proximity subjects the planet to immense gravitational and radiation forces, causing its atmosphere to stretch and form an elongated shape rather than the typical spherical form of planets. The intense radiation from the star heats WASP 12b to temperatures around 4,000 degrees Fahrenheit, making it one of the hottest known exoplanets. This heat has caused the planet's outer layers to expand and leak into space, forming a trail of escaping gases. Essentially, WASP 12b is being consumed alive, losing about 189 quadrillion tons of material every year. Astronomers studying this phenomenon have likened it to a celestial version of vampirism, where the host star is draining the planet of its lifeblood. Over time, this will result in WASP 12b being entirely obliterated, leaving nothing but a ghostly ring of debris around the star. This dramatic process offers a rare glimpse into planetary destruction, a stage in the life cycle of planets that's difficult to observe directly. WASP 12b's tragic fate reminds us of the fragile balance planets must maintain to survive the harsh realities of space. TRES 2b, the darkest planet. TRES 2b, located about 750 light-years from Earth, is often called the Black Planet due to its astonishing ability to absorb light. This gas giant reflects less than 1% of the starlight that hits it, making it darker than coal. Despite being bathed in the light of its host star, the planet remains eerily dark, with only a faint red glow caused by its internal heat. The reason for TRES 2b's darkness lies in its unusual atmosphere, which lacks reflective clouds and is rich in light-absorbing chemicals like titanium oxide. These compounds trap heat and light, giving the planet its pitch-black appearance. The lack of an atmosphere capable of scattering light further enhances its shadowy nature. Although it's cloaked in darkness, TRES 2b is incredibly hot, with temperatures soaring to over 1,800 degrees Fahrenheit. The stark contrast between its searing heat and its inky blackness makes it one of the most intriguing exoplanets ever discovered. Scientists are still unraveling the mystery of why TRES-2b is so exceptionally dark. Studying it could provide insights into atmospheric compositions and help identify similar worlds in the future. TRES-2b is a haunting reminder of how alien and diverse planets beyond our solar system can be. PSR B16 2026b Methuselah, the ancient planet. Nicknamed Methuselah for its incredible age, PSR B 162026b is the oldest known planet in the universe, with an estimated age of 12.7 billion years. That's nearly 3 times the age of Earth. Orbiting a binary system composed of a pulsar and a white dwarf, Methuselah is located in the globular cluster M4, about 12,400 light-years away. This gas giant challenges everything we know about planetary formation, as it emerged when the universe was less than a billion years old and lacked many of the heavier elements needed to form planets. Its existence suggests that planets can form under a broader range of conditions than previously thought. Methuselah's orbit around its host stars is both stable and extraordinary, taking about 100 Earth years to complete. This leisurely pace offers scientists a fascinating opportunity to study the gravitational interactions within its unique binary system. Despite its ancient origins, Methuselah is a robust planet that has endured countless cosmic events, including nearby supernovae and the gradual aging of its host stars. It's a true survivor, offering a window into the universe's earliest days. HD 189733b, the Glass Rain Planet. HD 189733b, a stunningly violent world, is located 64 light-years away in the constellation Vulpecula. This gas giant has an atmosphere dominated by silicate particles, which condense to form clouds of molten glass. The result is a planet where it literally rains glass, blown sideways by winds exceeding 5,400 miles per hour. The planet's deep blue hue, similar to Earth's oceans, is caused by the scattering light of these silicate particles. However, the similarities to Earth end there. With surface temperatures reaching a scorching 1,700 degrees Fahrenheit, HD 189733b is a hostile and volatile world. The extreme winds and glass rain are driven by the planet's tight orbit around its host star, which is completed in just over 2 Earth days. This proximity subjects it to intense radiation and tidal forces, fueling its chaotic weather patterns. HD 189733b is a prime example of how alien and extreme weather can get on exoplanets. Studying this world offers scientists clues about atmospheric dynamics and helps refine techniques for detecting similar phenomena on distant planets. Ogle 2005 BLG 390lb, the coldest planet. Ogle 2005 BLG 390lb, located a staggering 21,500 light-years away, is one of the coldest exoplanets ever discovered. Dubbed the Hoth planet after the icy world in Star Wars, this frozen super-Earth exists in the far reaches of its host star's habitable zone. With surface temperatures plummeting to minus 370 degrees Fahrenheit, it's a desolate, icy wasteland. This frigid planet orbits a faint red dwarf star, which provides little heat and light. The planet's vast distance from its star results in an extremely long orbital period, taking about 10 Earth years to complete one revolution. Despite its cold environment, Ogle 2005 BLG 390lb's discovery was groundbreaking, as it was one of the first planets detected using gravitational microlensing. Its icy surface suggests that it could potentially harbor frozen water, sparking curiosity about its composition and the possibility of life beneath its frozen crust. While unlikely to be habitable, studying Ogle 2005 BLG 390lb has expanded our understanding of where planets can exist and thrive. This frozen world highlights the incredible range of environments exoplanets can offer, proving that even the most inhospitable conditions can yield fascinating discoveries. And there you have it, the 10 strangest exoplanets discovered so far. Each of these alien worlds challenges our understanding of the universe and expands our imagination. If you enjoyed this cosmic journey, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, Keep exploring the extraordinary wonders of space.
What if I told you space isn't just a vast, beautiful expanse of stars and galaxies, but a terrifying, merciless void filled with things that could wipe us out in an instant? Rogue black holes, deadly gamma-ray bursts, and invisible forces shaping the universe. Space is far scarier than any horror movie. And the best part? We're completely powerless against it. Today, we're diving into the 8 most terrifying things lurking in space, and trust me, you'll never look at the night sky the same way again. Ready to explore the dark side of the universe? Let's begin. Rogue black holes. Alright, imagine this. A monstrous black hole, completely unhinged, drifting through space with no warning, no set path, and nothing stopping it. Unlike the ones chilling at the center of galaxies, rogue black holes are cosmic wanderers, silent, invisible, and devastating. Scientists believe there are millions of these roaming through our galaxy alone. That's right, millions. Now here's the terrifying part. These things don't just sit there, they move. If one were ever to pass close to our solar system, its immense gravity could rip planets out of orbit, or even send Earth spiraling into deep space. And the worst part? We wouldn't see it coming. Black holes don't emit light, making them nearly impossible to detect until they start warping the space around them. The only reason we know rogue black holes exist is because scientists have observed stars behaving strangely, suddenly speeding up or bending their trajectory as if an invisible force was yanking them. That's a telltale sign that something dark, something unseen, is lurking nearby. So, what's stopping a rogue black hole from one day wandering too close to Earth? Nothing. And that's what makes them so terrifying. Gamma-ray bursts. Imagine waking up one morning, stepping outside, and boom, the sky lights up with an intense flash of energy. No warning, no escape, just a blinding burst of cosmic radiation that wipes out everything in its path. That's a gamma-ray burst, GRB, one of the most powerful and terrifying events in the universe. GRBs are like space's deadliest sniper shots, fired from collapsing stars or merging neutron stars. These bursts release more energy in a few seconds than our sun will in its entire lifetime. If a gamma-ray burst ever hit Earth head-on, it wouldn't just scorch the surface. It could strip away our atmosphere, exposing us to lethal radiation and making life impossible. And here's the truly scary part. We wouldn't even see it coming. These bursts travel at the speed of light, meaning by the time we detected one heading our way, it would have already arrived. There'd be no chance to react, no time to hide, just a flash, and then nothing. Luckily, most gamma-ray bursts happen far away in distant galaxies. But what if one were aimed at us from a nearby supernova? Scientists say it's rare, but not impossible. And considering how little control we have over cosmic disasters, that's more than enough to send chills down your spine. Dark matter. Alright, let's talk about something truly creepy. Dark matter. It's everywhere, surrounding us, lurking in the universe, yet we can't see it, touch it, or even detect it directly. It's like the ghost of the cosmos, silently shaping entire galaxies while remaining completely invisible. And here's the kicker, there's 5 times more dark matter than normal matter. That means everything we can see, stars, planets, galaxies, only makes up a tiny fraction of the universe. The rest? An invisible force we barely understand. But if we can't see dark matter, how do we know it exists? Because galaxies behave weirdly. The way they spin defies the laws of physics, unless there's some unseen mass holding them together. It's like watching a Ferris wheel spin way too fast without flying apart. Something has to be keeping it intact. That something, dark matter. Now here's where it gets terrifying. Dark matter could be right here, right now, passing through us like a ghost. Scientists believe trillions of tiny dark matter particles may be zipping through your body every second without you even noticing. It's there, we just don't know what it is, where it came from, or what it might be capable of. The universe is mostly made of something invisible, something we don't understand, and if that doesn't send chills down your spine, I don't know what will. The Great Attractor. Imagine waking up one day and realizing that our entire galaxy, the Milky Way, is speeding towards something massive, something unseen, something so powerful that even light itself can't escape its grasp. Sounds like the plot of a sci-fi horror movie, right? Well, it's real, and scientists call it the Great Attractor. Right now, our galaxy, and millions of others, are hurtling through space at 1.3 million miles per hour toward a mysterious region of the universe. But here's the terrifying part. We don't even know what it is. This thing is so massive that it's warping space itself, pulling entire galactic clusters toward it like some cosmic magnet. So what is the great attractor? A supermassive black hole? A galaxy-eating void? Something we haven't even discovered yet? Scientists have no definitive answer. The worst part? We can't even see it. It's hidden behind the dense dust and stars of the Milky Way, locked away in a region ominously called the zone of avoidance, because even our best telescopes struggle to peer through. The great attractor is out there, waiting, pulling us closer with every passing second. And while it won't consume us in our lifetime, one thing's for sure, something gigantic and powerful is lurking in the dark, and we have no idea what it wants. Zombie stars. Just when you think a star's dead and gone, it comes back. Not as the bright, life-giving giant it once was, but as something far more terrifying. These are zombie stars, cosmic corpses that refuse to stay dead. Sounds like a horror movie? Well, space has its own version of the undead, and it's just as creepy. Here's how it happens. A white dwarf, what's left of a dying star, should just fade away into darkness. But sometimes it refuses to go quietly. Instead, it feeds. If there's another star nearby, this dead star starts pulling matter from its companion, growing in mass until, boom, it explodes in a violent supernova, only to leave behind another undead remnant. This cycle of destruction and rebirth keeps happening, making these stars the ultimate cosmic survivors. And if that wasn't eerie enough, there's a special kind of zombie star called a magnetar. This thing has a magnetic field a quadrillion times stronger than Earth's, capable of tearing apart atoms and frying electronics from hundreds of light years away. If one of these ever went off near our solar system, it could literally erase everything in an instant. So yeah, the next time you look up at the stars, just remember, some of them shouldn't even be alive. But they are, and they're still hungry. Rogue planets. Imagine a planet, a cold, lifeless, wandering world drifting alone through the darkness of space. No sun to warm it, no orbit to keep it anchored, no light to illuminate its surface. Just an endless journey through the void. These are rogue planets, cosmic orphans that have been violently ejected from their home star systems, doomed to wander the galaxy forever. Scientists estimate there could be billions of these rogue planets floating unseen in the Milky Way. Some are gas giants, massive and storm-ridden like Jupiter, while others are rocky, Earth-like worlds, frozen solid in the eternal night. But here's the terrifying part. Some of them could be passing right through our solar system and we might never even know. Since they don't emit light, they're nearly impossible to detect unless they block out a distant star as they move. Now think about this. What if one of these rogue planets was headed toward us? Even a near miss could disrupt Earth's orbit, throwing our planet into chaos. And if one actually collided, it would be game over. No warning, no escape. Just an unseen, drifting world appearing out of the darkness, sealing our fate before we even knew it was there. Cosmic void. Imagine floating through space, but instead of stars, planets, or galaxies surrounding you, there's nothing. No light, no warmth. Just an endless, infinite darkness stretching in every direction. Welcome to the cosmic voids, the loneliest and most terrifying places in the universe. These voids are massive. We're talking hundreds of millions of light years wide, completely devoid of galaxies, matter, or even dark matter. One of the largest, the Butte's void, is so empty that if our galaxy were inside it, we wouldn't have discovered another galaxy until the year 3000. Just try to wrap your head around that level of isolation. But here's the real nightmare fuel. Why do these voids exist? Scientists don't fully understand how such enormous regions ended up with almost nothing in them. Some theories suggest they're just extreme examples of how the universe formed, but others? Some believe they could be leftover scars from something even bigger, something that may have altered the structure of space itself. And if you think falling into a black hole is scary, imagine drifting into one of these cosmic voids. No gravity to pull you anywhere, no planets to land on, just infinite nothingness, forever. That's true horror, not death, but endless existence in the absolute absence of everything. Andromeda. Right now, at this very moment, a monster is heading straight for us. A cosmic titan, home to 1 trillion stars, moving at 250,000 miles per hour, locked in a collision course with our own Milky Way. That monster? The Andromeda Galaxy. It's the biggest, closest, and deadliest threat to our galaxy. And there's absolutely nothing we can do to stop it. In about 4.5 billion years, Andromeda will smash into the Milky Way in an apocalyptic merger that will completely reshape the night sky. The sheer gravitational chaos will rip apart solar systems, throw planets into deep space, and ignite a massive wave of new star formation. but at a cost. Some stars, including possibly our sun, could be flung into the abyss, left to drift endlessly between galaxies. And here's the eerie part. This isn't speculation, this is guaranteed to happen. Scientists have mapped Andromeda's trajectory with terrifying precision. Every second, it creeps closer, its spiral arms stretching toward us like a predator about to strike. But don't worry, you won't be around to see it. By the time Andromeda arrives, Earth itself might already be uninhabitable. So, in the grand scheme of things, maybe the universe is doing us a favor, wiping the slate clean before the real chaos begins. And that's just a glimpse of the terrifying mysteries lurking in space. The universe is vast, unpredictable, and full of things we barely understand. But that's what makes it so fascinating, right? If you enjoyed this deep dive into the dark side of the cosmos, make sure to like, share, and subscribe to InnoVision Tech for more mind-blowing space and futuristic tech content. What's the scariest space phenomenon to you? Let me know in the comments. Until next time, stay curious. Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother? You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure. The more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. The Soviet Union was a powerhouse of engineering, creating machines that often seemed to defy logic and imagination. From colossal aircraft to hybrid sea skimmers, their inventions pushed the limits of technology and design. Did you know the Antonov An-225 Maria still holds the record as the largest cargo plane ever built? These machines weren't just tools, they were bold statements of power and innovation. So get ready to uncover the craziest Soviet machines you won't believe actually exist. The Antonov An-225 Maria. The Antonov An-225 Maria is an extraordinary aircraft, often hailed as the heavyweight champion of the skies. Developed in the 1980s by the Soviet Union, its primary mission was to transport the Buran space shuttle, showcasing Soviet engineering prowess. This colossal plane boasts a wingspan longer than a football field, about 88.4 meters, and is powered by 6 massive engines, enabling it to carry an astonishing maximum payload of up to 640 tons. To put that into perspective, it can lift cargo equivalent to a small skyscraper. What truly sets the An-225 apart is its unique design tailored to handle such immense size and weight. It features 32 wheels spread across 6 landing gears, providing stability during takeoff and landing, and a distinctive twin tail to maintain control. This design allows it to transport oversized and heavy cargo that no other plane can manage, including massive turbines, industrial equipment, and even entire trains. Despite its unmatched capabilities, only one An-225 was ever completed, making it a rare and iconic marvel in aviation history. Beyond its technical achievements, the An-225 symbolizes the ambition and ingenuity of Soviet aerospace engineering. Today it continues to captivate aviation enthusiasts worldwide, representing a blend of power, innovation, and the spirit of exploration that defined an era. Its legacy endures as a testament to what human creativity can achieve in the skies. The T-35. The T-35 tank stands out as a unique and formidable machine from the 1930s, embodying Soviet ambition on the battlefield. What makes the T-35 truly remarkable is its 5 turrets, each armed and capable of firing independently. This multi-turret design was revolutionary, allowing the tank to engage multiple targets at once, a concept far ahead of its time. Weighing over 45 tons, the T-35 was essentially a fortress on tracks, built to break through enemy lines with overwhelming firepower. Despite its impressive size and armament, the T-35 had significant drawbacks. Its massive weight made it slow and cumbersome, limiting its mobility on the battlefield. Additionally, the tank suffered from frequent mechanical issues, which reduced its reliability during combat. These weaknesses made it vulnerable, especially against more agile and better armored opponents. Nevertheless, the T-35 remains a fascinating chapter in tank development history. It symbolizes a bold experiment in military engineering, reflecting the Soviet Union's desire to innovate and dominate through sheer firepower and multi-target engagement. While it wasn't a perfect design and saw limited success in actual warfare, the T-35's ambitious concept influenced future tank designs and remains an iconic example of early 20th century armored vehicle innovation. Its legacy is a testament to the era's daring approach to mechanized warfare. The Lund-class Ekranoplan. The Lund-class Ekranoplan is a remarkable hybrid vehicle that blurs the line between aircraft and ship. Designed by the Soviet Union, it operates using the ground effect, a phenomenon where a vehicle flies just meters above the water's surface, gaining lift from the air trapped between the wings and the water. This design allows the Lund to achieve incredible speeds, exceeding 300 miles per hour, which is faster than many conventional ships, and even rivals some aircraft. Powered by 8 jet engines, the Lund was primarily a military asset, built to swiftly transport missiles and troops across bodies of water like the Caspian Sea while evading radar detection. Its ability to skim so close to the water made it difficult to track, offering a strategic advantage. The vehicle's massive size, combined with its speed and low-altitude operation, made it an engineering marvel of its time. Only a handful of Lund-class Ekranoplans were ever constructed, emphasizing its role as a secretive Soviet weapon. Today, it stands as a testament to Soviet innovation and ambition, showcasing a unique approach to military transport that exploited aerodynamic principles in an unconventional way. The Lund remains a fascinating example of Cold War-era technology, symbolizing a daring blend of air and sea capabilities that few other machines have matched. The Buran Space Shuttle. The Buran Shuttle was the Soviet Union's ambitious response to the American Space Shuttle program, and it was really distinguished by some unique technological features. Unlike the US Shuttle, Buran was capable of fully unmanned flight and automated landings, which is honestly a remarkable achievement that continues to impress aerospace engineers to this day. In 1988, it completed its only orbital mission, circling Earth twice and returning safely without a crew on board. While the Buran's design was influenced by NASA's shuttle, it actually incorporated different engines and onboard systems, reflecting the Soviet approach to space technology. This divergence showcased not only technical innovation, but also a strategic vision that was really tailored to Soviet capabilities and goals. Despite its technological sophistication, the Buran program was short-lived. The collapse of the Soviet Union halted further development and missions, leaving Buran as a symbol of unrealized potential in space exploration. It represents a period of intense competition between superpowers, where advancements pushed the boundaries of what was possible in aerospace engineering. Today, Buran stands as a testament to Soviet ingenuity and the high stakes of the Cold War space race, embodying both the promise and the challenges of that era. Its legacy continues to captivate those interested in Soviet technology and the history of human spaceflight. The VDNKH robot. The VDNKH robot was an early Soviet experiment in humanoid robotics, designed to demonstrate the USSR's technological capabilities during exhibitions. This prototype could perform simple tasks and mimic basic human movements, showcasing robotics technology that was, honestly, pretty advanced for its time. Beyond its mechanical functions, the VDNKH robot symbolized Soviet optimism about the future, reflecting a vision where robots would support humans in industry and everyday life. Though primitive compared to modern robots, the VDNKH robot played a significant role as a stepping stone in robotics history. It combined engineering with theatrical showmanship, capturing the imagination of exhibition audiences and hinting at a future where humans and machines might collaborate closely. This early humanoid robot really exemplified the Soviet Union's drive to innovate and inspire through technology, blending practical demonstration with symbolic hope for progress. Its legacy lies not only in its mechanical design, but also in its cultural impact, representing a time when robotics was emerging as a field full of promise and possibility. The VDNKH robot remains a fascinating piece of Soviet technological history, illustrating how early robotics experiments helped shape ideas about automation and human-machine interaction. This aligns with broader Soviet efforts to push technological boundaries, as seen in other iconic machines like the Antonov An-225 and the Buran shuttle. The MAZ 7907. The MAZ 7907 is an extraordinary Soviet heavy transporter, designed to tackle the most demanding logistical challenges. Measuring as long as a city bus and equipped with 32 wheels, this colossal vehicle was engineered to haul massive rocket components and military equipment across difficult terrain. What sets the MAZ 7907 apart is not just its size, but, honestly, its sophisticated engineering. Each of its wheels can pivot independently, granting it remarkable maneuverability despite its enormous bulk. This capability allows the MAZ 7907 to navigate tight spaces and complex routes that would be impossible for ordinary vehicles of similar size. Its power and mobility make it a true marvel, capable of carrying loads that would crush standard transporters. The vehicle really exemplifies Soviet determination to overcome logistical obstacles with innovative, large-scale engineering solutions. Even decades after its creation, the MAZ 7907 remains one of the largest and most impressive transport vehicles ever built. It stands as a testament to Soviet ingenuity and ambition, reflecting a period when designing machines capable of extraordinary feats was a national priority. This aligns with other iconic Soviet technological achievements like the Antonov An-225 Maria and the Lun-class Ekranoplan, all showcasing a commitment to pushing the boundaries of engineering and transportation. The Caspian Sea Monster. The Caspian Sea Monster, officially known as the KM Ekranoplan, was a secret Soviet ground effect vehicle that amazed the world with its unprecedented size and speed. Measuring over 100 meters in length and weighing nearly 500 tons, it was designed to fly just meters above the water's surface, exploiting the aerodynamic ground effect to achieve remarkable stability and speed. Capable of exceeding 300 miles per hour, it was faster than most naval ships, making it a formidable military transport. Its hybrid nature, neither fully a plane nor a ship, blurred conventional engineering boundaries. This allowed the Caspian Sea Monster to carry heavy military payloads swiftly across the Caspian Sea while evading radar detection by flying extremely low. The vehicle's innovative design combined elements of maritime and aviation technology, creating a unique class of transport that was both stealthy and powerful. Despite its impressive capabilities, the project was eventually abandoned, largely due to changing military priorities and technological challenges. Nonetheless, the Caspian Sea Monster remains a towering symbol of Soviet innovation and secrecy during the Cold War. Today, it stands as one of the most fascinating and mysterious machines ever built, embodying the Soviet Union's daring approach to pushing the limits of technology and redefining what vehicles could achieve. Thanks for watching this deep dive into some of the craziest Soviet machines ever built. If you enjoyed exploring these incredible feats of engineering, don't forget to hit that subscribe button and ring the bell icon so you never miss an InnoVision Tech update. We love hearing from you, so drop a comment below telling us which machine amazed you the most or what tech topics you want us to cover next. Join the InnoVision Tech community, and let's keep uncovering the future of technology together.